Okay, so this is problem 10.3.43, and what they're asking us in this problem is, in how many ways could 21 people be divided into 5 groups containing 6, 7, 2, 1, and 5 people respectively? Okay, so the first thing that you want to think about in this problem is, you want to identify for yourself, are we talking about the situation where we have a replacement or we don't have a replacement? Remember the flow diagram that I talked about the other day. And this is a situation where you don't have a replacement. You're actually taking all 21 people and you're dividing them up. So it's not like you're assigning one person to a committee and then you're going to take that same person and assign them to another committee also so that they're on 2 committees. You're not doing that. So there's no replacement here. And then we have to decide, once we've decided no replacement, we have to decide, does the order matter or does the order not matter? And the order doesn't matter here. All we're doing is assigning people to groups, or we could think of it as groups or committees, whatever. But the order in which we assign them to those groups doesn't matter. If you assign Harry to group 1, whether you assign him first or assign him last, it doesn't matter. Okay, so that means we're talking about combinations. And what I'm going to do is I'm going to think of each of these groups separately. So if I want to talk about the group that has 6 people in it, if I assign them first, then I actually have 21 people to pull from, and I'm pulling 6 of them to get that group. So a combination of 21 things taken 6 at a time would tell me the number of ways that I could get, pardon me, this would tell me the number of ways that I could get 6 people assigned to a group of 6 from 21. Okay, and then I want to do the group of 7 next. So with the group of 7, notice that I've already assigned 6 people, so I don't have 21 to choose from anymore. I have actually 15, because if you take 21 minus 6, you have 15 people left. So for this group of 7, I can draw from 15 people. Okay, and then why is it doing that? Okay, sorry, my computer I'm looking at. Anyways, so with the group of 2, we're just going to use the same reasoning, the same process. So if we take 7 people out of this group of 15, we have 8 left over. So to assign the group of 2, I have a combination of 8 taken 2 at a time. And then I take 2 out of my group of 8, and I've got 6 left over. So I've got a combination of 6 taken 1 at a time. And then for my last group of 5, I have 5 left, and I'm choosing 5. Okay, so you actually would want to multiply this all the way out. It's going to give you a pretty darn big number. And then you would, get your answer there. I'm just going to do one of these because I think you guys understand how to do these. But combination of 21 taken 6 at a time, that's 21 factorial. It's over 6 factorial times 21 minus 6 factorial. Okay, so, you have this number here, 21, 20, 19, 18, 17, 16, and then times 15 factorial. I'm going to stop it at 15 factorial because my 21 minus 6 is 15 factorial. Okay, my 6 factorial, 6, 5, 4, 3, 2, and 1. So these 15 factorials will cancel, and then to figure out what this is, you're going to take the top, multiply it out, take the bottom, multiply it out, and then divide. And you'll get just the number for a combination of 21 taken 6 at a time. And then you need to multiply that number times each of these, and I'm not going to bother to go through them. The online program asks you to multiply these out, and on the exam, I'm not going to ask you to multiply them out. We can leave answers like this. It's just too much time. If I want you to multiply all of these out, then I'm not going to be able to ask you very many questions. So I will test if you can do this, if you can do a combination, but most of the problems I'm going to allow you to just leave your answers written in this form. Okay, all right, that's it on that one.